Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. So let's see what the problem is. The problem is split array largest sum. So what the problem is saying is we'll be given an array, right, as an input and k as another input, right? So what we want to do is we want to divide this array into k sub arrays such that the maximum sum of all sub arrays, right? Says the maximum sum of all sub arrays is minimum possible among the k splits. So for example, right? So if you see this example 1, 2, 3, 4. So what is the three sub arrays? So one sub array is this, another sub array is this, and another sub array is this. So the maximum sum of among the sub arrays is 4, right? How 4? So here the sum is 3. Here it is 3 and here it is 4, right? So we want to find out the maximum sum among all the sub arrays, right? And that needs to be minimum possible among k splits. That needs to be minimum. Okay. We want to find the maximum sum, which should be minimum among k splits. Okay. So this is the expectation. So let's see what approach we're going to follow. For example, we'll take the same example, right? So we are going to follow the binary search approach. Okay, the binary search approach. How? So let's see. We'll have a low and a high, right? Low and high indicates the sum, the minimum sum. Low indicates the minimum sum, right? And high indicates the maximum sum. Now low will be what? Low is the maximum sum among some arrays, among sub arrays, right? Maximum sum among sub arrays, so that it is minimum possible. So in this case, L will be, so what it will be among the complete array, the largest element, right, will be the low, right? Will be the low, right? Will be the low. Okay. Why? Because we want to find the maximum sum, right? Sub array sum, and it also needs to be minimum. So the maximum element, if we combine this 4 with 3, then it is going to be 7. Like if we combine the maximum element with any other element, right? With any other element, it is going to be more only, right? So the minimum will be this single element, which is a maximum out of, which is the biggest number out of these elements, right? And high will be what? The maximum possible sum. So it will be the sum of all the elements in the array. So it will be 10. 1 plus 2 plus 3 plus 4, it will be 10. Okay. Now what we're going to do is we'll create a mid, right? Out, and you know how to create a mid. Mid L plus H by 2. Okay. So in this case, it will be what? 14. L plus H 14. So 7. Mid will be 7. So mid will consider as a sum, right? We'll consider as a sum, right? The sub array sum, right? The sub array sum, and we'll try to divide this array, right? Considering this array into k sub arrays, right? Into k sub arrays, considering this sum, right? If considering this is the maximum sum, right? So what it will be? For example, 1, 2, 3, 4, right? 1, 2, 3, 4. So we'll have this element. We'll check whether it is less than this sum, right? Yes, it is. Then we'll check for the next element. We'll combine the next element with this, and we'll check, right? 1 plus 2. So it is still less than 7. Then we'll combine this 1 plus 2 plus 3, right? It will give us 6, right? Which is still less than 7. Then we'll try for the next element as well. That is 4, right? 4. So it will be 10. So which exceeds the 7. So we won't consider 4, right? So one sub-array we'll consider will be 1, 2, 3. 1, 2, 3. Okay. Then we'll take the next element for the next sub-array, right? So 4. So 4 is less than 7. Yes, it is possible. And 4 is being the last element. We cannot have definitely more elements, right? So that there will be two sub-arrays, 1, 2, 3, and 4, right? Considering the sum as 7, right? So in this case, when we have less than equal to k sub arrays, right? Now the expected sub arrays are what? It is 3, and we have got 2. So what we're going to do is, whenever we get sub arrays which is equal to or less than k, then we are going to decrement h. We are going to update h as mid minus 1, right? To check whether whether there is a lower maximum sum possible, right? Possible to divide the array into k sub arrays. We have to minimize, right? The maximum sum we have to minimize, right? So we're going to try this. Now mid is what? 7, right? So we'll try with h now. H equal to 6. Okay, h equal to 6. So what is L? L will be unchanged. L will be 4 and h will be 6, right? So now mid will be what? Consider this. 4 plus 6, 10, right? 10 divided by 2, it will be what? It will be 5. Okay, it will be 5. Now what we'll do again, we'll have this array, right? Array, and we'll check, right? We'll take this first element. If it is less than the sum, max sum, right? The max sum, then we will try to include the next element as well. So 1, 2, it will be 3. 3 is still less than 5, right? So we'll try to have the next element. 1 plus 2 plus 3, it will be 6, which exceeds 5, right? So we won't include 3. We won't include 3. So we'll have this, right? 1, 2 as one sub-array. Okay, we found one sub-array. Now we'll take the next element for the next sub-array. 3. 3 is definitely less than 5. So we'll consider 3, right? And then we'll check for the next element if it is possible, like 3 plus 4 equal to 7. So it is exceeding 5, right? It is exceeding 5. So we cannot include 4 in this current sub-array, right? We cannot include 4 in the current sub-array. So what we're going to do? we cannot do. So we'll have only this single element in the second subarray. Now we'll go to the next element for the next subarray, right? 4. 4. So 4 is definitely less than 5. We can have this in the subarray. Now this is the last element. So we got 1, 2, 3 subarrays, right? So whenever we get less than equal to the k subarrays, right? So this we have got 3 subarrays, right? And k equal to 3, right? So whenever we get less than k equal to less than or equal to k subarrays, we are going to decrement this max sum, right? We're going to decrement to find whether less than this current sum, it is possible or not, right? As we want to minimize the maximum sum. So we'll have, again, we'll decrement, we'll have h equal to mid minus 1. Mid minus 1, that is h will be 4 now, right? So L is unchanged, L is 4, h is 4, right? If it had been the case that we are getting subarrays more than k, right? If we would have got 4 or 5 subarrays, right? Then what we would have done? We would have incremented the L, right? In order to have lesser, in order to have in order to have the greater sum, right? And if you have the greater sum, then the subarrays are going to reduce, right? Right? And when we get less than equal to k subarrays, then we are going to decrement h, right? So in order to right, in order to increase the subarrays up to k or increase the sum. Okay. So yes. So now the current state is L equal to 4, h equal to 4, right? So again, mid, what it will be mid? 4 plus 4 divided by 2, right? It will be 8 divided by 2. Again, it will be 4, right? Mid. So this sum is 4 now. So again, what we're going to do is we're going to check, right? 1, 2, 3, 4, right? And sum is what? Sum is 4, right? So we'll check this element is less than 4. Yes, definitely. We'll consider the next element as a part of the subarray, right? Next element as a part of the subarray. Yes, 1 plus 2 is 3, which is less than 4, right? Now we'll check for the next element as well. 1 plus 2 plus 3 is 6. No, 6 is exceeds 4. So we cannot have 3, right? So we found one subarray, right? 1, 2. Now we'll consider 3 for the next subarray, right? For the next subarray, yes, 3 is less than 4. Definitely we can consider. Now we'll try for including 4 as well. So 4 plus 3 is 7, right? It exceeds 4. So we cannot consider 4 in the current subarray. So we'll consider 4 in the next subarray. 4 is less than equal to 4. Yes, we can consider this, and this being the last element. So we have found the 3, right? We're going to find, we have found the 3 subarrays, right? Whose maximum sum is 4, right? Now we'll again try to find out whether the sum lesser than this is possible or not. So what we'll do? Again, mid minus 1 will do. H equal to mid minus 1. H will be what? H will be 3, right? Mid minus 1, 3. And L will be 4, which will be unchanged. Now L is greater than, right? L is greater than H. So we cannot proceed further because L needs to be less than equal to H, right? This is the basic condition of binary search, right? So we'll break away. So what we have found the solution as, sum will be 4, and we have found the three subarrays as well, right? So this is the answer, right? This is the answer. Okay. So the maximum sum, which is minimum among the 3 splits, among the k splits, is 4, right? So this is a solution. Let's quickly do a code walkthrough. So here, right? So here, if you see, so L, right, H. Now what we're going to have is L will be the maximum element in the array, as I've already explained, right? Maximum element in the array. L will be maximum element in the array. And H will be what? The maximum, that is, L will be the maximum element in the array, which will be minimum, right? And H is what? The sum of all the elements in the array. Okay. Then what we'll do? We'll have here H. See, condition is L should be less than equal to H. And then L plus H minus L, right? So this, like, this is equal to L plus H divided by 2. So for bigger numbers of L and H, so this is how we calculate the mid, right? This is how we calculate the mid. So we have calculated the mid, which is the sum. Now we are checking whether it is possible. So if it returns, when it will return true, when the subarrays, the count of subarrays is less than equal to k, right? The count of subarrays is less than equal to k. So we will first initialize answer. We'll consider this as an answer, right? Whatever the sum. So first, if it is 7, then we'll consider this answer, and we'll check for lower sum now. Mid is 7, right? For example, mid is 7. Now we are going to mid minus 1, 6, right? So we'll consider whether lesser sum is possible or not, as we want to minimize, right? So we'll have H initialized as mid minus 1, right? And then we'll again go through this, right? Go through this, right? And if we if we have more subarrays, right? Then we want to increment the L, right? In order to decrease, right? More subarrays than K. If we found 5 subarrays, right? With whatever was a mid, right? Which is sum. We have 5 subarrays. So we have to increment the lower, right? The L, right? In order to decrease the, in order to have k subarrays, right? So we'll here do L equal to mid plus 1. Okay, in this way. Now we'll see is possible, right? So what it is doing, it is creating the subarrays. So how we'll create the subarrays? So for example, we'll have count, we'll have sum. This count sum is the subarray sum. Okay, so we'll iterate through the elements, right? And we'll count plus I. So here, what is count sum is 0, right? So I is what? 1, for example. So in this case, let's quickly see, right? So we'll also, let's see this through an example. Okay, let's try to do it faster, right? So yes, so for example, right? So what? Let's consider 1, 2, 3, and 4, right? And Let's consider this mid as 4, right? Mid as 4, right? Now, what we're doing, we are checking count sum. Count sum is 0. 0 plus I. I is what? The first element, right? First element, right? If it is greater than mid, right? Is it greater than mid? Mid is 4, right? So no, it is not greater than mid. So we'll include this element in the current subarray, right? So count sum has become 1 here, right? And then again, we'll take the next element here. We'll consider the next element 1 or 2, right? So we'll see count sum is 1. I is what? 2. 1 plus 2. Is it greater than mid? No, it is still not greater than mid. So we can consider. So count sum has become 3 now, right? We have considered this in the subarray. We've considered these elements, right? Then again, we'll have this one, right? So count sum is 3. 3 plus I. 3 plus 3. It's 6. It is definitely greater than mid, right? Which is 4. So this is a subarray count. Now it was 0, right? So we will not include this I, right? We'll not include this I in the current subarray. So count has become 1. Count has become 1, which is one subarray. We have found one subarray, which is 1 comma 2, right? Now we'll initialize the count sum, right? So it will be what? Count sum will be 3 only, 3, this one. So count sum has become 3 here. Okay, the new subarray, the start of new subarray, 3. Okay, the start of new subarray. Then we'll again check, we'll take the next element here, we'll check 3 plus 4. 3 plus 4 is greater than mid, right? So we cannot include this I, but we found one subarray, right? We found one subarray, so we'll increment the count 2, and we'll also initialize count sum as a new subarray, which will be 4 equal to I, right? Then again we'll check, right? If it is less than count sum plus I. No, so we are done over here, right? So this was the last element. This I was the last element, which is 4, right? So we'll come out of this for loop and we'll check whether count sum, which is 4, right? Which is 4. If it is less than equal to mid, it is, then we'll increment the count, right? We have found another subarray, right? Because count sum is less than equal to 4, right? For the last element, we have to check this, right? We have incremented 3 and we are returning whether we are checking, we are returning true or false, whether count is less than equal to k. Count is the number of subarrays. If it is less than equal to k, if it is less than equal to k subarrays, then we are going to return true, else we are going to return false. So this is the solution, right? Right? I hope you have understood the solution. Okay. Thanks for watching. Please subscribe to my channel. Please like the video. Have a happy, healthy, and a great day. Thank you so much.